Okay, today we're going to try to come up with a rule to find the area of any figure. Remember before we had previously talked about as long as the graph is above the x-axis, the definite integral represents the area underneath the curve. So what we're going to do with all these problems is sketch a graph and come up with the definite integral to represent the area and then use our calculator to come up with the value. So first thing we're going to do on all of these problems is make a rough sketch. So y equals x squared is my parabola, and I'm only looking at the region bounded by the curve and the x-axis from 0 to 2. So this is the region I want to find the area of. And remember what we're doing when we integrate is we are adding up infinite number of rectangles from 0 to 2. So the height of the rectangle is x squared. The width of the rectangle is dx, so this would be the area of one rectangle. Integrating it from 0 to 2 adds up all the rectangles from here to here, and this would represent the area underneath the curve. And we're going to use our calculator to evaluate these, so you guys can check for yourselves, but this is going to give me a value of 8/3. Okay, second one. We're going to look at the graph of negative x squared, which is a parabola that opens down. And we're going to look at this graph from 0 to 2. So this is the region I'm looking for. Okay, now if you just integrate this from 0 to 2 of the function like we did above, because the graph is below the x-axis, you're going to get a negative 8/3 for my answer. But notice the question says I want the area, so I want the answer to always be positive if I'm asking for area. So there's a couple things you can do. I can go ahead and put an opposite sign in front of there, so really this becomes positive, and this would also equal 8/3. Or you can go ahead and keep it like this, but then flip my bounds, which would make it the opposite, and you would get 8/3 this way. So the goal here is always to come up with a definite integral that represents the area. So you always want your answer to be positive. Okay, let's get the next figure. The graph is y equals 3, which is just a horizontal line, bounded by this line, the x-axis, and we're only going to look at the graph from x equals 1 to 5. Okay, this is just a rectangle. I know what the area of this is. It's 4 times 3, which is going to be 12. So I know geometrically I can come up with it. But again, I want to come up with a definite integral. So think about coming up with one rectangle. So the height of the rectangle is 3. The width of the rectangle is dx. That will give you the area of one rectangle. Integrating from 1 to 5 will give you the area of the entire rectangle. And again, we're going to use our calculator. That will give me 12. Same thing when you do it geometrically. Okay, let's get the next one. Y equals 3 is one graph. And then I'm also looking at the graph between y equals 3 and y equals 1. So this time I'm looking at this region. Again, it's a rectangle, and I can do it geometrically. This is 2, this is 4, so obviously the area of that rectangle is 8. But again, I want to come up with a definite integral that represents the area. So let's think about your one rectangle. The height of this rectangle would be 3 minus 1, and I'm going to leave it like this, which is the same as 2. The width of the rectangle in all of these is dx. So this is the height of the rectangle, this is the width, this is the area of one rectangle. I'm going to add up all the rectangles from 1 to 5, and you can check this on the calculator. It should lead you to 8. Okay, let's get another one. This time the function is y equals 3, y equals negative 2. And again, my x bounds are going to be the same. I'm only looking at this graph from 1 to 5. Okay? So again, you've got another rectangle. So let's think about geometrically, what would this be? The entire height is really 5, and then the width again is 4. So I know the area of this rectangle is 20. But again, let's think about how we can come up with a definite integral to represent the area. What I recommend is draw in one rectangle and think about what the height of that rectangle is. It's really 5. The way that you're coming up with the 5 is it's the 3 minus a negative 2. So I'm going to write it like this, which I know is the same as 5. That's the height. The width is dx. Bounds are still going from 1 to 5. And if you do this in the calculator, you will get 20. hopefully you see a pattern for what's happening to get to the height of this rectangle. Okay, try the next one on your own and see if you can come up with a general formula for finding the area. You can pause the video real quick. Okay, so let's see how you did with the next one. So I want the area of the region of y equals x squared plus 3. That's just the parabola moved up 3 units. And y equals -2, which is a horizontal line here. And we're going to look at this graph from 0 to 5. So this is the region that I'm looking at. Now, there's no way I can come up with the region, the area of the region geometrically. So we do have to come up with a definite integral. But same thing that we did before. Let's think about one rectangle in that region. What's the height of the rectangle? Notice the height is the parabola all the way down to -2. So it's going to be x squared plus 3 minus a -2. Notice on the previous ones that we did, how do we come up with the rectangle? Notice it's always the top function minus the bottom. It doesn't matter where the functions are. It can be above the x-axis, below, but you always do top minus the bottom. So same thing here, top minus the bottom. That's going to give you your height. dx is my width. Add up all the rectangles from 0 to 5. So this would represent the area of that entire region that I've shaded. And if you check this on your calculator, I believe it's 66.6666 repeating. So the general rule for finding the area of any region bounded by two functions, where f is the bigger function, is, so the bounds are a to b, so we're going to add up all the rectangles from a to b. The height of the function is always the bigger function minus the smaller function, so that would be f of x minus g of x in this case. That's the height of the rectangle. This is the width of the rectangle.